added them since I made it, but I'll add it today.
I'll let you know tomorrow what the first and last questions are. This might not even be on the final, so I'll look at that. Write it down, but it might not be on the first exam. So we've got a little game of billiards here. You're playing, and you observe a perfectly elastic collision. How do you think what you observe would differ compared to if it was completely a perfectly elastic collision? Because in the real world, obviously, there is going to be a little bit of energy lost. So what would be the most noticeable thing if you did somehow observe a perfectly 100% momentum and energy conserved elastic collision? What's that, Noah?
They would bounce off each other, and the cue ball would go back in the direction it came from.
That's true. That's true. There is one other thing, though, and I thought you were actually symbolizing it with what you were doing.
It'd be like a slip.
It's equal.
Energy will be transferred. Energy would be lost, like due to vibration, right?
Yeah.
So if we have no vibration, what effect would that have on what we observe?
No energy would be lost?
No sound. Exactly. From the person who's not actually in this class. Well done. Because if there's...
No vibrations and energy lost due to vibrations, would be no sound.
Exactly. You lose energy to that vibration, and without that vibration, you're not going to hear anything. So yeah, there would be no sound.
So that's the...
Yep. What's it?
What day is our exam?
Our exam is on Wednesday.
Okay, stop.
Yep.
No, I didn't take any
One day. All multiple choice.
How
Today's notes. Tomorrow is a study day.
Would you think of any chance you'd have it graded by Friday?
Oh yeah. I'll probably have it graded before you guys leave.
92.3, so if I get anything below an and this, I'm going to have to write the essay. I just want to make sure I have time.
Okay.
But I got all the answers.
Good.
I found an answer.
I have a feeling you'll be just fine.
I found an answer.
So I understand that like D's not the right answer, but if I put D
Well, how do you know that that's not going to be?
and I say this is what I wanted to do in regular physics and I forgot to do it. So if Yoda answers all D, what is 100%?
That's a good question, and I'd have to think of a smart way to answer
Last
that.
year, I didn't know the answer to the essay. Well, I didn't know, but I didn't want to do it. So I turned it into a multiple choice question and wrote D next to the essay. Then I figured it wouldn't work, so I erased it, and then I wrote the essay, and I did good.
I was going to say, I don't remember seeing that.
No, we talked about it.
Oh, we did.
Okay.
Okay.
Because there were so much erase marks,
Right.
and then I told you that was my plan, but I ended up writing it.
Okay, so in terms of what we're doing today, I'll get more into tomorrow later. We got to finish up, but we're not going to actually be talking about momentum today. The other thing in this section has to do with center of mass. So label your notes one-dimensional center of mass, or 1D center of mass.
I don't have any more loose.
I have one.
No, I have this. It's just not in my binder. I almost made it to semester. I have the graph paper. Euclid's?
No.
1D center of mass. One-dimensional.
Fabuloso.
Oh, you look pretty average today, Placido.
These are definitely my pajamas.
So,
Oh,
nothing? Don't ask questions.
Oh, no, not a pipe bomb.
So, not doing that again. So, center of mass is just the average position of all the mass of a particular object. So, maybe, this thing right here. Where do you suppose the average position is for mass on this object?
somewhere in the middle.
Yeah, somewhere in the middle. Did you say fiddle?
No, I said middle.
Okay, yeah, in the middle. So, right in between my fingers here would be your center of mass. It's the average spot where all your mass is. Some objects are easy to determine like this. And this is also relatively easy to determine. It's not going to be in the exact middle like the last one.
It's probably gonna be on the edge of the burn, like the label.
Yeah, right about here.
That's true.
What's that? What, like this? Yeah, I mean it will go right down the middle, but it's in 2 dimensions, of course. So it will be straight up through the bat, and then in this dimension it will be located right here. So that would be your sweet spot on the bat.
Oh, all I heard was squishy.
What about this ball right here? Where is its center of mass?
I don't know, but if you spit out your finger, you can find it everywhere.
Everywhere.
It's not everywhere.
It's
It's only one place.
It's where the air pump is.
From the
The
bottom.
little tiny hole.
Right here?
Yep, that's the center of mass.
Okay. But I mean, wouldn't the center of mass be
From the
further
bottom.
like
The
this
center
way? Because
center.
No, it's
On
inside.
the bottom.
what?
Inside the
From
center.
the bottom.
From the bottom?
It's the absolute center, Mr. Hathaway.
From
It's
the
like
top.
inside at the absolute pinpoint center.
Okay. Yeah, that's absolutely right. So when we look at a ball like this,
What I said.
the center of mass is the very middle. And the point you need to know about that is that you can have a center of mass in a position where there is no mass. Like in the middle of this ball right here, or like in the middle of the piece of duct tape. Center of mass is right there, even though there is no mass there. It's just the average of everything. So, enough of that. So in terms of the math,
You guys
In
are
terms
just
of the math of math. We talk about the math.
I'm the mass. I'm the
This is
mass.
exciting. That's a different class. Oh, that's
in the x direction, your center of mass is defined as follows. I knew you were missing that symbol.
Ew.
We just did
Ew.
two on Friday.
Monday.
What day? Monday.
Isn't today Monday?
Yes, that's yes.
I don't know why my other Christmas lights aren't working, but that's kind of depressing me.
It really is.
Work.
I don't know that that's gonna help you.
You're right. I need to whip them around more.
I'm
One of your
canceling
lights is
it.
out then.
The sum sign.
So this is our
Why
equation.
can't you do that?
And it would it would read like this: the sum of all of your masses times your distances divided by the sum of all your masses. So you're adding up the product of all your masses and distances in the numerator. On the bottom, you're just adding up all the masses. That's all it is. So let's do a quick example. You can write this down.
Why can't we cancel that?
But
You will.
Girl, what is this?
So draw that as best you can.
wait, so what is the unit when you solve that?
It depends on what your distance unit is. Usually it'll be meters.
Oh, okay. I see.
Or maybe it will be a unitless distance, like the second example we're going to be doing in here.
That's
You guys
gross.
remember in like second grade when you had to solve a math problem and put units and you had to make up your own units? You had to
No.
put, like, you guys didn't get to do that?
No.
They'd give us like, they'd be like, what's 10 plus 8? And you had to do like 18 and then you had to put units so you could put whatever you wanted.
They would just make us write units squared.
Yeah.
Oh, dude, we have to pick whatever you want. My teacher was like, alright, so you can pick giraffes. Or
So your
pick
teacher is
apples.
better than ours. Is what you're
Dude,
saying?
my teacher was freaking fun.
What did you pick for your units?
Depended on the day. Sometimes it could have been dogs. Sometimes it could have been dogs, trees, Mr. Hathaway's.
You knew Mr. Hathaway?
Yeah, of
Yes,
course.
of course.
No, he was the teacher.
Yeah. That makes sense.
This class is great.
Ender said that we are 8th hour next semester too. So look
Yeah.
forward to that.
Well, yeah, they keep
I'm
AP
trapped
classes
in
the
a
same
job
hours.
Oh, do
try
they?
to. They try to keep AP classes the same hours.
10 years here, I never picked up on that. Says something,
I mean, it's also because that's the only time it fit, really.
I suppose.
Because this is one most students have libraries.
So I'll show this to our television audience, our television neighbors, and then we'll go through it together.
They're our classmates. They just don't know it yet.
Yeah. Just think, somebody watching this video might be in like 2nd grade right now.
Oh,
I was thinking about it the other day, and I was like,
Hey,
the
make sure
freshmen were born in like 2006 or like 2007. Like that seems like
Okay,
like that
Always
seems wrong.
fuck around blinder.
Like
My
that
sister's in
seems
second
wrong
grade.
to
She's like
me.
class of 2031 or something. That
Yeah.
just sounds crazy. That just doesn't make
It
like
sounds
sense.
wrong.
Stop, I don't need this today.
What?
What year was she born?
2016 or 13?
He wants to fun math.
No.
Take your current age and divide it by 100, and think about that's exact. Like 100 is like the age people live at like the most, and you live that long or whatever.
Girl, I've been having like a
Okay, you
since
just-
like 14.
Okay, so let's work through this together.
Let's go.
Time to come on back. So if we want to actually solve this, we just have to follow the directions. Add up all the masses times all the distances. So, all right, guys, come on back. Here we go. Reel it in. If I have to add up all those masses times their distances, then I've got m1 times x1, and I've got m2 and x2. And that's all divided by the sum of both masses, which is m1 plus m2. Questions? Good. Yes?
What's your favorite variable?
That's a good question. I don't know. I kind of like x. X is fun. What's your favorite variable?
Definitely not you.
No,
Yes,
you
I is actually something. Therefore, I.
So, yeah, that's how we do this one. Your center of mass would obviously be closer to M2 than M1 because this one's heavier.
No, it wouldn't.
Okay.
No. No, it wouldn't.
Ow.
Apparently, that was too easy, which is why we're going to change this
No, we're
1
not.
to a 7.
See, you really?
Hold on.
Not to.
Mr. Hathaway.
7-dimensional center of
A
mass.
7 and an extra stick at the bottom.
Yes, Placido.
The equation was m1x1 plus m2x2 over m1 plus m2.
Yes.
Okay, thank you, Jalen.
So if we're doing 2-dimensional center of mass, it's the same story.
Do you guys remember when we did the 1D thing on math?
That was a great
Remember
Bro,
when
those
there
were
was
the
just
days.
numbers? There were no letters in the alphabet, and then wait, what's the number alphabet called?
Can the units be
The
numbers?
Digits, integers,
Yeah, sure.
Cool.
Like
numbers.
counting?
Do you remember when there were actual numbers in that?
I don't know, but I remember it.
I don't
I can
see
go with my
any
dad.
numbers.
You know, there's a number.
There's one number. There's two.
Wait, that's a
But
third
that's not even
dimension.
in math, that's the title.
Oh, yeah. Well, you could go for as many dimensions as you want. Whatever's beyond z, I actually don't know. But the problem that we're going to be doing as an example will be a 2-dimensional one.
Should we put XD?
Wait, so this is technically 3D?
These are the 3 terms, but our notes are just going to be doing an example of 2-dimensional. So the main thing that you need to know about this is that if you would have to deal with some sort of 3-dimensional center of mass, you're going to have to answer it then in component notation, which I know you've been missing.
I got that. Every time I
Yes.
do it,
You
I
know,
think
when
of
I
the
put that in the
secret.
quiz, I was like, wow, I did not miss this. That's the only thought that came to my head. But besides that, no complaints.
What?
So you'd answer in that term, and this is how we're going to answer the example that we'll be going through here.
It's even
It
not
looks
scary, but
it's
it's
so scary.
simple.
You think this is scary? Wait till we get to our next thing on what we're closing with. You guys are going to love it.
It's really
You're going to love
not.
it.
As bad as it looks, but it looks.
Hey, Mr. Hathaway would never lie to us. Personally. Wait, can you move that for 3 seconds, please?
Oh, sure.
1,
Axiom.
2, 3.
What would it give me if I can spin this a full time on my head?
I think it would be easy for you.
High
to do.
five.
I would
Wait, watch
allow.
out for the
I
tree.
would say yay.
Oh.
If you can do it one full time, I would allow for you to cancel our exam.
Well played,
I
sir.
would give
Well
that
played.
to you. Try it. It's okay. It's worth the risk. I tried to get Lang in camp because his final is a project and we're seniors and it's one semester to exempt us from our last memory work instead of like exempting us from a final.
Why are you doing food?
I don't think it works.
Yes, that's what she meant.
Oh, I was so
Yes.
confused.
Not laying
Yep.
Leave it
I was
alone,
like,
it's
what?
fine.
I got so confused for a second.
College and career ready.
Everybody's like, wait.
Let me struggle. It's okay.
As I listen to it and I'm like, okay, I think she meant someone with an L. Oh, yeah, okay.
I don't know how I get them mixed up. Like they're totally different, but like I get them
Hi, Sarah. How are you doing today?
not good.
Oh, well, I'm sorry to hear that. Now you need to apply to all of these colleges because I said so.
Why isn't it in the middle of the triangle?
I
She's already applied to that
even.
college.
Flamingos and Christmas trees. I never thought I'd see those together, but there they are on your
Wait.
face.
Where?
What? You're
Aren't those flamingos and Christmas trees
Oh
there?
yeah, I was so confused.
But you haven't seen it before? Wait, dude, I'm pretty sure in Good Luck Charlie Christmas there's a scene.
That movie was good.
I'm gonna add that as not an absolutely amazing movie.
Best movie
When they're at the pool. Yeah.
Yeah, which
Have you seen
highway
Bob Duncan and
you
his
see
Daffy Love
lots of
Story?
flamingos on a hill.
Oh, on the Rock Highway, right
The
before.
rock highway
Yeah, it's called the Rock Freeway or whatever.
in numbers.
I don't know the numbers.
Just
It's
keep
the
going.
Rock. It's meant so if you're coming from school, it would be right before the Racine one, but you have to see it from going to Racine to Portland.
All right, so let's
I
take a
drive
look.
every day from work, and
We'll take a look at our example here
It's
then.
called the Rock Freeway.
So these objects are not necessarily connected. Where their center of mass is going to be the same regardless of whether they're connected or not. But you can see we've got a 2m here, 1m there, 4m there, just representative of how heavy those masses are. And you can see we're going in 2 dimensions here. So we have to solve for this. And let's see where it takes us.
Can they be 3 sharks?
Sure.
Sharks.
We need our
Wait,
shark
how are
problem.
those
They can be cookie cutter sharks.
Grab
Because
a
they
thing.
look like little cookies. Actually, those are very deadly sharks. You don't want those to come at you. What they do is they latch on and they twist their bodies super fast and they bring out a chunk of your skin. I'm sure you wanted to know that.
Why would it
What's that?
Because when you look at the wound, it looks like they bit a cookie.
Exactly. So, if we want to solve this, we are going to be doing the center of mass in the x and y directions separately. So, in the x direction, mx all divided by the sum of the masses. So, in the x direction, we've got 2m multiplied by the distance d.
I'm learning
Then-
to be quiet.
Yeah, have a seat, folks. Let's keep going here. And then we've got 1m times the distance. Actually, sorry, b should only go this far. My mistake.
I'll forgive you, John.
So squiggle that out. Those of you at home, the letter B only goes that far. It does not go the entire distance.
Now they're very confused.
So, M then is a combination of D and B. You have to add these two distances together in order to get that distance for letter M. So, it'll be M times D plus B. With me so far?
Yes.
Okay. Then we've got 4M. It's the same distance. D plus B. And when you add up all of the masses, you get to 7, I think. So that's what we have.
Why did you do 4M?
So that's 4.
Oh.
That's the fat
So
shark.
It's a ratio of M. It's
Yeah.
not actual like.
Yep.
I read it as 4 meters. So.
So, if I want to do this math, I think the first thing I'm going to do is just toss out the m's because they suck.
What about homie say that?
Yeah. So let's see here. 2D or not 2D. And then we've got D plus B plus 4D plus B. So that'll be 5D plus B. All divided by 7. I'm going to go ahead and multiply this through. So we've got two versions of D here. We've got 2D plus 5D, so that'll be 7D.
Where did the M's go? I'm sorry, I did not.
They canceled all out.
7D! We made it! We did make it to 7D.
And then we've got 5B.
Wait, was this planned? That's actually supposed to be 70.
No. Yes.
We good so far?
Yes. Let's say it was planned.
Okay. So now I guess we can, let's see here. We'll just cancel out those 7s.
D plus 5 7 B.
Yeah.
D plus 0.71.
So congratulations, you're halfway done with this problem.
We always say XCM equals D plus 5 7 B.
So that's in the I direction. Yes?
So does D this XCM always equal D plus 5 7 B?
No. That's just for this particular example that uses sharks.
Wait, that's just in the I direction?
Yes. Because this is all for X. So this is all the I component. Everybody got this down?
Oh, this makes sense now.
Cool. Yeah, it's not supposed to be complicated. The next part's supposed to be complicated.
Great. It's like it would be 0. You just multiply by 0, but then you have all the
Now, actually, the Y direction is much easier.
Yeah.
So, Y direction. So, in the Y direction, 2m times what's its height?
0.
Yeah. M times its height, which is? Yeah. And then we've got 4m, which is a loser because it does have a height. So we actually have to do something. 4m times h. Yep.
That's actually simple.
All divided by 7m. So, let's go away again.
4 over 7H.
Yep.
So what do D and B represent again?
They just represent certain lengths. So then this would be in the J direction. So your final answer then for component notation would be the x1, which was D plus 5/7 B.
Honestly, just writing this as a
And there's your component notation final answer.
This is how my notes turned out.
And this is where babies come from.
I was so confused where that's taking me.
All right. You guys ready for some fun?
Yes.
No.
Let's go.
All right.
3D center math?
No, we're done with centered mass.
I
Today.
really want him to pull out something entirely random, not related to AP Physics at all.
You are going to be learning.
Santa.
You are going to be learning something that you can brag to everybody about from here on out. For today, in AP Physics, you will be learning officially rocket science. So, go ahead, write this in your notes.
Have you ever gotten a reaction like that?
I've gotten several different reactions.
Believe me, I would be more happy if I had the emotional.
That's why you just say
Anyone
it.
else just wants this week to be over?
Okay, that's the thing.
I wanted this week to be over last week.
Clean cut.
I was not feeling school today.
I was not either. I really wanted
I'd
to just
rather be
wait that.
nothing at all than say.
We're a week away from ending everything,
Is it
but
natural
like,
law?
I wanted.
Yes. Yeah, that's a curse of L and N there.
Yes! Not quite right there. But I feel ya.
M-O or M-E?
Oh.
I'm thinking.
It's me.
Mo. Mo. Mo.
Where did Mr. Hathaway go?
What song? Oh yeah, that was Mask Off.
People are gonna be so confused what we're talking about.
I'm not okay.
I feel so bad for whoever has to watch these debates.
The thing is, you really can't hear us. But then again, I've never listened to one where I was in the classroom. Because I do them when I'm not there. Yeah.
That's okay. No
Mr.
one needs
Halfway
to be
volume all the way down, class volume all the way up. Mic is all the way up.
Just give it all mics. Mr. Hathaway, you should put in notes, turn the volume up.
Right.
Can
Must listen with headphones.
Can we do it again where you project it on the screen and then it's like the...
Oh, you know what we should do? This should have the capability to like record things in 5.1 surround sound, so that like if I set speakers up, you could hear it exactly like how it was. Like your voices would come out of that speaker, and Flaccido, you'd be in that speaker.
Good morning, everyone.
That would be cool.
It's time for lunch.
Why?
Are you in your mic on?
I gotta take this off soon because everybody in my family's a hater. No, I'm gonna see if my family's a hater.
Your family didn't want you to wear that big cool.
They don't even know that I bought it. Hey yo, family, I am not in a maid costume right now. I am completely normal clothes. It's
I mean, you do. But
I'm in my
they're
purpose
under it.
suit.
Oh, yeah.
Nice. Are we rocking it?
We sure are.
Yeah. The Christmas tree?
Oh yeah.
Can you
No
put
one-
rockets around a Christmas tree? I feel like that's how your Christmas tree would be decorated.
Just
Can
with
we
rockets.
A Christmas tree off with rockets.
Yes.
Yes, we can.
All right. So, for the folks at home,
There you go.
this is what it looks like here. You might want to pause this at different places because it's a bit taller than the screen. So a little bit about rocket science here. And there's a couple important things that we can deduce just by what's written here. Number one, this is a funky looking equation. V is the final velocity of the rocket. This is the original velocity of the rocket. VE is the exhaust velocity. This is how fast those gases that are being ejected out of the back are actually coming out. It's a very, very high number. So natural log of MO over M. Well, that's odd. Why would we have two different masses? Are you okay?
Massive.
Those flamingos. Yes.
The MO is the mass of the original before the gases are expelled, and M is after the gases are expelled.
Exactly. Unlike everything else we've done so far, mass no longer remains the same. It changes over time. So this is the original mass, this is the final mass. Thrust is your force exerted on the rocket by the ejected exhaust gases, and that's what causes the rocket to go forward, even out in space where there's nothing to push off of. It's just those gases that are coming out the back that push it forward. That action is plenty. So the thrust equation is, it's a force, so it's mass times acceleration. And of course, acceleration is simply a rate of change of velocity. So you could write it this way, but again, it's not necessarily our velocity that is changing the most here. It's our mass. So it's really the ejected velocity of those gases multiplied by the rate of change of the rocket's mass. And this is what we'll be making use of today. Questions on this so far? So this here is the rocket science equation, and I'll just show you exactly how it works. One or two examples, and you guys will be just fine. Yes?
Why natural law? I don't know. I'm just curious. Just why a natural law?
That's just how the math breaks down in that relationship.
Well, oh my my goodness, this is throwing me off because it looks like e to the natural log, and I really want to cancel it.
Oh, I see. Nope.
I saw that too.
Okay, so let's
It's not
get
a longer
this set up.
equation.
What is?
That's all.
We have a rocket.
I am a rocket scientist.
It has an original velocity in this direction. And that original velocity is going to be equal to 3,000 meters per second.
Oh boy.
Yeah.
I guess it has to go fast.
Sure does.
I like that.
Then,
3,002 meters per second.
They're double.
it launches the rocket. And that gas is ejected out the back. I was waiting for some sort of comment on that one. 5,000
We were all thinking it.
meters per second.
The bottom of it.
So we've got this scenario here, and my first question would be,
Keep the gas out there.
what is the velocity when it has used up half of the fuel, when its mass is half of what it originally was? Because the biggest mass on a rocket by far is the fuel. So we're going to look for the velocity when we are at half the original mass. So, let's take a look at our equation. So that's our equation there. We know a lot of this information. We know the original velocity. We know the exhaust velocity. So in order to find that final velocity here, we need to make sure we can bring this to a number. Can we do that? Yeah, it's 2. Because when we're at half the original mass, that just means that this final mass here is equal to 1/2, or 0.5, original mass. So m original divided by half m original is equal to 2. So now it's just a matter of doing some math then.
Oh.
You good?
Oh, colors. I struggle.
Major.
Only has red and green on the board.
And then it's just a matter of plugging in your numbers.
Flower.
That's from me from like a month ago.
Yeah,
It's been up there all the time.
It's been up there quite a while.
it's been up there for a while.
I think the sink has moved.
On my calculations, it has moved about an eighth of a tenth of a quarter of a centimeter.
Be more creative with those units, Jaden. 1/10 of a dog.
You've had practice.
The average, the
Yeah, you
average
should
dog
have
size.
time this year.
Right, this is literally what they trained me
I've been trained.
So when you plug all this into your calculator, you'll end up with 6,470 meters per second.
Oh yeah, because you like to ride.
3 digits for me.
You're hurting my head.
So there you go. We do have one more we want to go through in terms of rocket science. This will be the last example that we do in class until we come back in 2021.
As long as I can fit it on my paper.
Questions on this?
I've got about 5
Okay.
lines. Is that enough?
Oh yeah. This one will be pretty short.
Wow, I really just tried to pull eraser stuff off.
Let's say...
Ah.
Wait, where?
Oh, sorry, I thought you were done.
Fuel equals food.
I really like the progression of all those sounds.
So we'll say that the fuel is burning at 50 kilograms per second. So if that's how fast it's burning, we should be able to calculate the force of thrust that the rocket is experiencing. And we have our equation for thrust. It's mass times acceleration, which ultimately comes down to the exhaust velocity times the rate of change of mass. And we're given the exhaust velocity. It's still, 5,000. Now what about this dm dt? Any idea what we do with this? Good guess. Good guess. You're thinking too hard.
Just leave it alone. We plug in the rate of change. We plug in the rate of change.
What's that, ladies?
Is it just 50?
It's just 50. Because
Mass?
this is the rate of change.
Yep.
Yeah. This is the rate of change of mass with respect to time. And that's what we're given. 50 kilograms per second is how quickly that mass is changing. So we're given this number.
But do you want to change it to anything?
I don't want to, do you?
I mean, I wouldn't mind changing it to 0.
That'll be a slow-moving spacecraft. So if you do this math, you get 250,000.
But like, now you have meters. Oh, haha.
What if when you're in your car, you're not moving the road?
And that is rocket science.
Did you guys ever have to do like one of those like I'm an entrepreneur, what invention